Students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the lecture number 9 on electrochemistry. Before going to discuss the relevant topic in this lecture, let us recap what we have already studied in different lectures. In the first lecture that we have studied regarding the introduction to the electrochemistry. In that lecture we have discussed how electrochemistry, what is basically we are going to study in the electrochemistry. And in that regard we have discussed about the most common electrochemical cell, that is the Daniell cell. In the second lecture what we have discussed about how we can able to represent a cell, electrochemical cell, and how we can able to measure the cell potential from with the help. In the third lecture we have discussed about the applications of the electrochemical series. Electrochemical series, you will find it is a basis for the electrochemistry. How we can able to construct a cell, that is going to, this electrochemical series going to guide us in this regard. In the fourth lecture we have discussed about the Nernst equation, because so far we have discussed about the cell potential, which is based on the standard cell potential, which is basically standard cell potential, and which is based on a specific concentration of the electrolyte solutions. But from the Nernst equation we can able to calculate the cell potential of any cell having any concentrations, electrolytic concentrations. In the fifth lecture we have discussed some important relationship, like the relationship between the standard cell potential with the equilibrium constant, with the change in the Gibbs free energy with the equilibrium constant, and the change in the Gibbs free energy with the standard cell potential, that we have discussed in that lecture. In the sixth lecture we have discussed about, again, a very important topic, that different types of batteries. That we have discussed the primary battery, secondary battery, and how the cell reaction is going to occur to produce, to convert the chemical energy to the electrical energy, that we discussed. In the 7th we have discussed some very important definitions regarding the conductance of the electrolytic solutions. Different type of conductors we have discussed. In the 8th lecture we have discussed about the different type of conductors, that is the electrolytic conductors and the electrolytic conductors and the electronic conductors, the metallic conductors, and how we can able to measure the resistance of a electrolytic conductors, that we have discussed by the help of the conductivity cell. Now in this lecture we are again going to discuss the very important two things. First we are going to discuss regarding the molar and equivalent conductivity, molar and equivalent conductivity, and second we are going to discuss the impact of concentration of the solution of the electrolyte on the conductivity. These are two important things that we are going to discuss. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First let us understand the molar conductivity or equivalent conductivity. Basically, when we see that different electrolytes, when it is dissolved in the same solvent, the difference of the conductivities of this electrolyte differs because of number one, that is the charge of the ions, number two, that is the size of the ions, and number three, the concentration, means that ease of flowing of these ionic ions in a given potential difference. And to accommodate all these informations, we need to have a new physical quantity that is called the molar conductivity, or it is called another terms, that is the same thing that we will discuss now, equivalent conductivity. The two things that we will discuss, that's molar conductivity and the equivalent conductivity. So what is molar conductivity? Let us first understand. Molar conductivity, we can define this molar conductivity. Molar conductivity, that is represented by the lambda m, and it is the conductivity or we can say the molar conductivity of solution at V dilution is the conductance of all ions produced in the solution. Produced in the solution when number one, 1 mole of electrolyte, 1 mole of electrolyte dissolved in V centimeter cube of solution. Number one. Number two, the distance between the electrode, the distance between the electrode is 1 centimeter. And number third, the cross section, of electrode is sufficient enough to contain all the solutions. So we can understand the molar conductivity is basically a conductance of the solutions having the volume V centimeter cube, or we can say VCC, wherein there present 1 mole of the electrolyte, and the distance between the electrolyte is 1 centimeter, and the cross section of the electrode, distance between the electrode is 1 centimeter, and the cross section of the electrode is sufficient enough to contain all the solutions. So here you can see that we have included the concentration term, concentration of the electrolyte. In the simple conductivity, you can see that it is basically the conductance of 1 centimeter cube of the substance. Here we have included the concentration terms, that is the 1 mole of electrolytes in case of molar conductivity. So we can relate this conductivity, that is the molar conductivity, with the conductivity, normal conductivity, that is a kappa. This is basically molar conductivity lambda m, and it is represented by lambda m. So molar conductivity is basically, you can see, conductivity kappa into V, because this is the conductivity of the 1 cc of the solutions, and here molar conductivity is V centimeter cube, conductance of the V centimeter cube of the solution, where there is a 1 mole of the electrolyte. Okay, so this is K into V. Now this V term we can express in terms of concentration or in terms of molarity, and that is K into 1000 divided by Cm, where Cm is the concentration in terms of mole per liter. It is basically the concentration in mole per liter. Mole per liter. Mole in terms of liter. So we know moles per liter means it is nothing but the molarity. So we can further write K into 1000 divided by molarity. So molar conductivity with the conductivity can be related with this, that is K into 1000 by molarity. Now what is the units of this molarity? Let us understand. Units. See, in this term, molar conductivity is basically Siemens per meter when we take in the SI unit, Siemens per meter, and here you can see there is a inclusion of a term liter, volume term has been included. So this unit will be, you can see, that is Siemens. K is the Siemens per meter, Siemens by meter, into meter cube. Meter cube is basically, that is the coming from the volume terms. So its unit, and it is also by mole. Mole will be in the denominator. So you will get this unit is Siemens meter square mole to the power inverse. Further, you can in the another units that you can see when we express in the centimeter square, that is here you can see. So it will units will be Siemens centimeter square by mole inverse. That is also the another units. So we understand the units of the molar conductivity. So now another terms, that is the equivalent conductivity. Equivalent conductivity, it is very simple, same thing. that in equivalent conductivity we will just replace 1 mole by the 1 equivalent gram equivalent of the electrolyte. In place of 1 mole, you will give the 1 gram equivalent. So you just write this concentration term CEQ. Further, you can write this equivalent conductivity EQ is equal to K into 1000 divided by normality. Because here concentration that in terms of equivalent per liter. So gram equivalent per liter, you know that is the molarity. So we get the equivalent conductivity. So we understand now what is molar conductivity and what is equivalent conductivity. And this unit of this equivalent conductivity will be like this. It will be Siemens meter square by equivalent inverse. So for this equivalent conductivity, we will get this. This is basically simple, that we have replaced the 1 mole of the electrolyte in by the 1 gram equivalent of the electrolyte. That will give the equivalent conductivity. So we understand the molar conductivity and the equivalent conductivity. Now we are going to understand what are the impact of the concentrations on those conductivities. That is the conductance, conductivity, molar conductance or equivalent conductance. Between the concentration of the electrolyte solutions with the conductance, with the conductivity and the molar conductivity. As the concentration is increasing, or we can say as the concentration is decreasing. As the concentration is decreasing means the dilution of the solution is increasing. Means we are diluting the solution by adding water, means the concentration of the solution is increasing. Then what is going to happen on the conductance? Conductance, that we know, that is being represented by G. Conductance will going to increases. It will increases. Why? Because as we are concentration is decreasing, means we are diluting the solution of the electrolyte solution. The more amount of the ion has been produced. The dissociation of the ions has been increased. For the weak electrolytes, that we will understand later on, and for the strong electrolytes, that is the attractive interaction between the ions goes on decreasing, and that is why as the number of ion is increasing, the conductance will going to increases. So what will be the conductivity? Conductivity means kappa. What will be? Because we know conductivity is basically the ions per cc. Ions per cc. That means as we are diluting this solution, means we are decreasing the concentration of the solution, there is a decrease in the conductivity, because in the denominator you will find this a volume term. So when this is increasing, naturally this conductivity is going to decreases. And number 3, the molar conductivity. What about the molar conductivity? Because we know molar conductivity is K into V. As the V is increasing, the molar conductivity will going to increases. Although the conductivity terms, this will going to decrease, but its decrease will not much significant to cancel the importance of the increasing of the volume. So what is going to happen? The molar conductivity will going to be increases. As we go on increasing the dilutions, in diluting the solution, means the when the concentration, when we can write this, when the concentration, that is C, is tends to 0, when the concentration tends to 0, there at that time the conductivity, or we can see the molar conductivity, is called the limiting molar conductivity, and that has been represented by lambda m0 or lambda m infinity. This is called the limiting molar conductivity. As we goes on decreasing the concentration, means concentration is tends to 0, this is almost 0. This is called the limiting molar conductivity. Limiting molar conductivity. So we understand what is limiting molar conductivity, where the concentration is tends to 0. For the strong electrolyte, we can relate this limiting molar conductivity with the conductivity at the concentration C with this equation. This equation is this. This is the equation, and this equation is called the Debye-Hackel-Onsager equations. This equation is called Debye-Hackel-Onsager equation. This is called the Debye-Hackel-Onsager equations. This equation, you can see we are relating the conductivity, molar conductivity as the concentration C with the limiting conductivity, and there is a term you can see that is A is constant. It is the characteristics of a electrolyte. For the same solvent and the same temperature, this A depends on the electrolytes. And when we are going to plot this equation, what we will find? Suppose we are plotting this equation where in the y-axis this is the concentration, root over of the concentration, in the this is the x-axis, root over of concentration, in the y-axis we are plotting this molar conductivity. What we will find? We will find that there is a negative slope. You can see this is a negative slope. For the strong electrolytes, suppose it is KCl, this plot will be like this. This plot will be like this for KCl. For weak electrolytes, that is CH3COOH, this plot will be this, and you can see there is a negative slope, because as we increase the concentration, the conductivity, molar conductivity goes on decreasing. and its slope is, the slope of this curve is the minus a. This is the slope of this curve, it is minus a, and it will intersect at the y-axis with this lambda m0. Lambda m0 means that is the limiting molar conductivity. What we find from these two curves, we find a very important thing, that for the weak electrolytes and for the strong electrolytes, the curve is not same. The nature of the curve is totally different. You can see for the weak electrolytes at the initial concentration, there is a different trend. But as the concentration is decreasing, means we are diluting the solutions, increasing the dilution of the solutions. After some time, there is a continuous increasing of the molar conductivity. And in case of weak electrolytes like acetic acid, you will find initially there is not much of a change of the molar conductivity, but when the dilution is very much appreciable, significant, at that time you will find there is a steep increase of the molar conductivity. Now, why it is so? Because at the initial concentration there is a attractive interaction, and when we are diluting, the attraction between the ions goes on decreasing, and this will enable the ions to transport the electricity on the larger scale, and that is why its molar conductivity is going to increases. And in case of acetic acid, you can see initially you know this is a weak electrolytes and its dissociation is not much, but as one goes on increasing the dilution, the concentration is decreasing. At the appreciable time, there is a 100% dissociation of this electrolyte, and this will going to contribute to this increase the molar conductivity. So we understand all the things. It's a very, very important thing. Now we do one very important numericals. KCl aqueous solutions. Aqueous solution of KCl. We are adding AgNO3. Then what about the molar? What about the molar conductivity? There is an option is given here. We are increasing the dilution, and this is a molar conductivity, and the equation So the fourth option is given here. When we add KCl in aqueous solution, when in aqueous solution of KCl, in aqueous solution of KCl we are adding aqueous solutions of AgNO3, then what is going to happen for this molar conductivity? The fourth, there is a fourth option is given here. Then what will be this option, or this or this? So here you can see, when KCl means aqueous solution of KCl means it has a K plus Cl minus R, and when we are adding AgNO3, at that time what is going to happen? KCl plus Ag plus NO3 minus. At that time what is going to happen? There will be the reaction between the Ag plus and the Cl minus. So there will be the precipitation of the AgCl. So you will find K plus NO3 minus and plus AgCl. Right? So what is going to happen? Initially Cl minus has been replaced by the Ag plus. So in the solution you can find the Cl minus is replaced by Ag plus, and Cl minus is react with the Ag plus and it is replaced by NO3 minus. So there is no such change in the number of ions in the solution. That you can see in the solution Ag plus NO3 minus, and there is a AgCl PPT of the AgCl solid. So as we goes on increasing the concentration, the AgCl, the dilution of the AgCl, AgNO3, we are increasing the AgNO3. When we are increasing the AgNO3 concentration of AgNO3, what is going to happen? It is not dilution, you can say AgNO3. We are adding the AgNO3, then what will going to happen? Time will come, at that time all the Cl minus will be consumed by the Ag plus ion. There is a precipitation, and after that, at that time K plus NO3 minus, the ions is will be constant. So if the ions is constant, then molar conductivity will be constant up to this point. And as it goes on increasing the AgNO3 solutions in the KCl solutions, so after that what will happen? The Cl minus will be finished, but Ag plus and NO3 minus will be goes on increasing. So after this point, when this complete PPT has been produced, after that there will be the increasing of the conductivity. So this will be the right answer. So that is all for today's lecture. In this lecture we have discussed about the molar conductivities, equivalent conductivities, and the impact of the concentration on all those conductivities. Thank you very much for watching, and in the next lecture we will discuss another very important topic in this equilibrium, in this chapter. Thank you very much.